Okay, so that question there is saying a uniform 400 Newton boom is supported as shown. Find the tension in the tie rope and the forces exerted on the boom by the pin at point P there. Okay, so that's the question that we have. We can try to draw the sketch there that we have in that order. So sketches in physics are very important. Before you start solving your question, be able to identify. The most important thing in physics is to be able to identify what you have to work with. That's the most important thing. Okay, so that is what we have. Then we have that force there. And the weight of this object will be concentrated at the center of the boom. That will be where the weight will be. So this is the tensional force acting in that direction. So this is tensional force. We have been given this distance here to be 1/4, which is L/4.
Sir.
Yes, please.
Which question are you doing?
Okay, this is question number 5 from your tutorial sheet. Huh?
Okay.
You check your tutorial sheet, question number 5. So that top part is given as L/4. And this part from the pivot here, we'll take as our pivot, where the hinge is 3L/4. So that is 3L/4. And somewhere here you have an angle 50 degrees. 50 degrees. Okay, so you have two forces here. We have a force. I have a normal force, which is exerted upwards. Okay, you have two component normal forces here at the hinge here. You have the normal force, which is pushing upwards. If you want, you can call it H, so you can give it any name you want. If you want, you can call it FNY. If you want, you can call it H, it's fine. Then the X component normal force, we can call it P. We can call it P there. So those are the forces that we have there. Those are the forces that we have. Okay, so one thing should be known is that this incidence here is a bit different from that one we had. Okay, that one we had, we were given some base here. We were given some base here and we were given the distance of this base here. But here, we've not been given that base, but we have been given this slant part, which is the length of the boom there. Okay, so that we should be very careful as we attempt questions of these involving angles. Okay, so when you are summing your forces, you don't consider the pivot. You don't consider where the pivot is. Okay, you only consider forces. If you are summing your forces, you assume you have no pivot. The pivot comes in as you start dealing with the torques. As you start dealing with the torques, that's when the pivot will come in. Okay, so here, again, the question here can be solved using the summation of the forces should be equals to 0. Okay, so this includes forces in the X being equals to 0 and forces in the Y being equals to 0. Okay, so that is what we have there. So we've been told, so in this question, we should find the value of P, we should find the value of H, and we should find the value of T, which is the tensional force. So we should find 3 forces here. Okay, so that question you posted in the group there should be approached in the same manner. We're going to approach this one. Okay, you should approach it in the same manner. Okay, so I'm quite sure that we can find this H force, the normal force, along the vertical direction or along the Y there. Okay, and for us to be able to find this normal force along the Y, we'll just sum the forces along the Y. We'll just sum the forces along the Y. And the summation of the forces along the Y should be equals to 0. Okay, should be equals to 0. Because we can sum the forces along the X, but we don't know the value of P. We don't know the value of T. So we don't know also the value of T. So we can try to find the value of H. Okay. Also use it to find the value of T. And from there, if we find the value of T, it will also be equal to the value of P there. The value of P. Okay, so the forces along the Y, we have the H itself being positive because it is pushing up, minus this weight of the boom there, which is it 400 newtons. Then this force here is 2000 newtons. So that is what we have in that order. So we have 400 newtons minus 2000 newtons. This should be equals to 0. This should be equals to 0. Okay, so if we add these two, they'll give you some value, which is 2400. And this will be equals to 0. Therefore, the value of the normal force pushing along the Y will be equals to 2400 newtons. So this is the value of this normal force at point P. The value of the normal force at point P. Okay, is there any question before we proceed?
Sir, can you repeat the explanation?
Repeat your question. I didn't get your network is cutting. Hello, repeat your question.
Asa, she's asking if you can read the question.
In physics, but I was looking at.
There are too many people talking, so I didn't get anything. One at a time, please. Ask that question.
I was saying, can you repeat that point?
Okay. Your network was still cutting, so I didn't get anything. Maybe try to text them there. But the question asked in the inbox there, the H, yes, is the normal force. So this is point P. Point P is here where the hinge is. Okay, so we have been told that we should find these forces here. These forces acting at point P. At point P, we have two normal forces acting there. We have the normal force along the X. We also have the normal force along the H, along the Y, which is H. Okay, so this H here is the normal force at point P. okay, is the normal force at point P, which is acting along the Y. So that is our first part there. That's our first part. So we're remaining with two parts for us to solve this question. We need to find the tension, and we also have to find the P force, which is the normal force along the X. Okay, so for us to be able to find the P, we need to sum forces along the X, and it should give us 0. Okay, we have P being positive and T being negative, and this should give us a 0. But here we don't have any of these forces. We don't know the P, we also don't know the T. Okay, so we resort to the torques for us to get the tensional force. We resort to the torques for us to get the tensional force there. Okay, so I'll move to the next screen. Okay, so we can draw another free sketch which will help us to get the torques. Which will help us to get the torques here. So we have a force here. We have a force here. Okay, we also have a force there.
Sir, can I please see the previous board?
Okay, here's the previous board. Okay, we proceed.
Yes.
Okay, so here we have tension in this direction. But if we choose our pivot to be here, it means that we won't have any, the forces at that pivot, they won't cause any torque. Okay, but remember that we have an angle here of 50. We have an angle of 50 there. Okay, and the displacements that we have are along this line or along that boom. So for you to be able to get your torque, okay, for you to be able to get your torque, the force has to be perpendicular to the displacement. Okay, so you draw components of these forces here. You draw components of these forces. So you draw component, this component in that direction. Okay, so that is a component in that direction. And when it goes down here, it will also be a component. Then you come to the top there, you also draw a component in that order. Then it will also come down here. It will also come down. At some point, they'll be able to join there. Okay, so that is what we have. And for this T as well, we also draw a component which will be perpendicular to this plane here. Okay, which will be perpendicular to that boom. That is what we have there. That is what you have there. Okay, so now when it comes to the angle, remember that this will be able to make an angle here. We're going to have an angle there, and we also have an angle here. Okay, so for us now to find that angle, we can try to join these as triangles. Join these shapes as triangles. So you have a 90-degree angle. So here you have 50 plus 90, then you subtract 180. It gives you this angle here, which will be 40. Okay, which will be 40. Again, this is making a 90. If you subtract 40 from 90, it gives you a 50. So these are the angles we're interested in. Okay, if you extend this again, it touches this part here. You have a 90-degree angle there. Okay, you have a 90-degree angle of that sort that you have there. Okay, so if this is our 90-degree angle here, what angle are we having here? So you are mathematicians, you need to know how to solve for these angles.
Sir,
Yes, please.
is this your first board after the first question?
No, it's our second screen.
May I see the first one?
Okay, the first one is this one. Okay. Okay, we proceed. Okay. Time is not quite with us. Told you are supposed to have biology at 12. Okay. So if you are able, if you do the evaluation on how.
Sir, please go to the previous board. I didn't take the screenshot.
Sir,
Yes, please.
uh,
I can't get anything. The network is cutting.
I was logged out when you were explaining this part.
Me too, sir. Can you just go through before you end the call?
Okay. Okay. Okay.
So I was saying that I didn't understand that part.
Okay. Yes. Okay. So what we are actually doing here is that we were taught to find the forces at point P, and we also find the value of T. Okay, to find the value of the tensional force there. Now, for us to find the, for us to be able to get the forces, you know that we can approach these questions using two conditions: the summation of the forces, okay, or the summation of the torques. That is how we can solve these questions here. Now, if we sum our forces along the y, okay, if we sum the forces along the y, we can find the value of this force here, of one of the component forces, which is at point P. So this H here is the normal force along the y. The P is the normal force along the x there. So if you sum our forces which are along the y, we have the 200 Newton weight, we have the 400 Newton weight. These are both of these are negative forces, okay? And we add also the H there, which is a positive force. And if we do our evaluation, we'll be able to get our force, which is H, one of the forces at point P. Now, we are remaining with the T and the P. For us to find the P, we need to sum the forces along the X. But along the X, we don't know any value of the force. We don't know the value of T, we don't know the value of P. Now, for us to get the T, we sum the torques. Okay, we sum the torques. And this is where we were now, in summing the torques. Okay, in summing the torques. Yes, please.
I'm not clear. Why did we add H if P is the pivot? Why did we include the H when finding the forces in the y-axis?
Okay, yeah. So this P which is here is different from the point P. We've just named this force as P. If you want, you can name it as Fn X. It's any letter you want, you can give it. If you want, you can call it Fnx. Okay, if you want, you can call it G. There is no harm. Okay, but the point here is P. The point there is P. Okay. So we'll be able to finish this part, the other part tomorrow. we have consumed some 7 minutes for biology. So see you tomorrow. Just go through these. They are very simple. Okay. So